Molarity is a unit of concentration. Before we can begin discussing molarity, we've got to look at a few definitions to make sure we're clear. First, let's go over the word solute. This is the chemical that is being dissolved. Solvent, the chemical that does the dissolving, this is going to be present in the greater amount. And in our chapter, the solvent is always going to be water. In fact, water is such a common solvent that when something is dissolved in water, forms an aqueous solution, it has its own phase, AQ, in parentheses. So water is known as the universal solvent because the water molecule is so good at dissolving so many different types of chemicals. You may recall that water is a very polar molecule and it's able to dissolve many other polar substances. For example, sugar, and there are dozens of types of sugar, but this is table sugar, C12H22O11, and when it's dissolved in water, we would write it in this form. And this is ethyl alcohol, otherwise known as ethanol, C2H5OHAQ. When it's dissolved in water, this is how we would write it. Acetic acid, CH3COOHAQ, that last hydrogen is the acidic proton, and then table salt, NaCl. All of these substances dissolve in water, and to show that they are dissolved in water, we write the chemical formula and then AQ in parentheses. The solute would be the chemical that has the formula, and the solvent would be water. We care about solutes as chemists because it's generally the solute that's doing the chemistry. So there are many ways to quantify concentration, which is basically how much solute there is per solvent. However, a unit that is often used by many chemists is the unit of molarity. And molarity is often signified by a capital italic M, and it is always the moles of a solute divided by the liters of solution. So if we look at this equation, we can see there are three ways to manipulate this equation since there are three variables. We can solve for molarity if we're given moles of solute and liters of solution. We can solve for liters of solution if we're given moles of solute and molarity. And we can solve for moles of solute if we're given molarity and liters of solution. I really recommend you write these three different equations down, because as you go through your molarity problems, you're going to be using one of these three, and you have to use the right one to get the right answer. So as you solve molarity problems, the first thing you want to do is very clearly identify which quantities and units you are given and what you're solving for, and that will help you know which of these three equations to use. You have to be given two values out of the three, or at least enough information to get two values out of the three. Sometimes you may have to do a little extra dimensional analysis work. For example, you may have to convert between moles and grams. Remember, the conversion factor between moles and grams is the molar mass. It's an added step where you have to calculate that, but that's what you have to do. So to get to moles from grams, you divide by the molar mass, and to get to grams from moles, you multiply the molar mass. If you set up your railroad math correctly, your units will cancel out and you'll end up doing the correct mathematical operation. The other type of dimensional analysis that you might see in molarity problems is conversion between milliliters and liters. And this is a simple conversion factor. 1,000 milliliters is equal to 1 liter. So molar mass, milliliters to liters, you will have to do some of those conversions. So let's try it. If we have 0.020 moles of NaCl dissolved in water to make 50 mils of solution, what is the molarity of the solution? So pause this for a minute, look at your notes, look at the equations, and see if you can come up with the answer. When you get an answer, start the video again and we'll go over it. So I always write out what I'm given in the units and what I want. And one of the things that I have found very, very helpful is when I use molarity in one of these problems, I always break down the units into moles per liter. So I'm given moles, I'm given volume, and I'm solving for molarity. To solve for molarity, I need liters, and I don't have liters. So I've got to convert my milliliters to liters by using the railroad math and remembering that 1,000 milliliters is equal to 1 liter. So 50 milliliters is equal to 0.05 liters. And now I have moles, and now I have liters, and I can solve for molarity, which is moles of solute per liters of solution. So when I plug these values into my calculator, I get 0.4. It's not exactly right. I want correct sig figs. It would be 2 sig figs since this value has 2 sig figs, and when we divide and multiply, we use the value that has the least sig figs to determine how many sig figs our final answer should have. And then my units are going to be either moles per liter or molarity. If you got that, give yourself a pat on the back. The next set of videos will have more practice problems.